This is the test review for our first exam. This exam is going to cover sections 1 through 11, which is our introductory section. We're going to talk about some linear equations and inequalities. Then we're going to deal with functions and then lines and then systems of equations. So that's the majority of what we're looking at here. Let's look at question 1a. So what we want to do on these questions is order of operations. So we're going to start with inside the parentheses first. So we're going to go 3, and then we're going to go 1 minus 5 is negative 4 squared plus 16. So I just did the inside of the parentheses first. After parentheses, it is then exponents. So we have negative 4 squared. This is very important. The negative and the 4 are both being squared. And we have to square that before we multiply the 3. So we're going to go negative 4 times negative 4 is 16 plus 16. Then we'll do the multiplication here. That would be 48 plus 16. And then we add that, we get 64. So the final answer then would be 64. Part B, we need to simplify the top of the quotient line and the bottom of the quotient line, or the numerator and the denominator. When you have something in a numerator and in a denominator, it's kind of like considering parentheses of each of the whole things on the bottom. So we do those separately first, and then we can divide. So I'm going to work on that top part first. We have 6 squared, so that would be 36 minus 15. And then on this bottom part, I am going to do the inside of the parentheses first. 2 minus 6 is negative 4 plus 4. Okay. I want to do that multiplication on the denominator. So 5 times negative 4 is negative 20 plus 4. And we can go 36 minus 15 is 21. All right, the last thing to do here is we're going to take that 21, keep that on the top, and then we're going to go negative 20 plus 4 is negative 16. I need to then just check to see, can that be reduced at all? The factors of 21 are 1, 21, 7, and 3. The factors of 16 are 1 and 16, 2 and 8, 4 and 4. So they have no common factors. So our final answer then, I'm just going to write that negative out in front, and I'm going to write 21 over 16. So negative 21 over 16. Remember that one negative makes the whole expression negative. If I had a negative on top and a negative on bottom, we would have a positive expression. So there are the problems where we need to simplify the expressions using order of operations. The next questions that we need to do is solving linear equations. Now with linear equations, just remember that it's almost like you have a scale, and whatever you do to one side of the equation, you have to balance with the other side of the equation. So let's take a look at this first one. We have to simplify the expression on the left side, and we're going to simplify the expression on the right side. When we do that, we don't have to balance because we're just simplifying. So I'm going to distribute the 4 through 4x minus 24 plus 19 equals 6. Now this is very important. We need to make sure we distribute the 2 through, but also the minus sign. So we're going to go negative 2 times x is negative 2x. Negative 2 times positive 1 is a negative 2. All right, so I'm going to combine like terms here. We have 4x minus 5 equals 4 minus 2x. I'm just going to now that I have my expression simplified, now we're going to want to start doing things to both sides of the equation. So in this case, I want to bring this negative 2x over to the left side. So to undo the 2x on the right side, I need to add 2x. But if I do it to the right side, I need to do it to the left side. 4x plus 2x is 6x. Then I need to bring that 5 over to the right side. So to undo the 5, I add 5 to both sides of the equation. So that would be 6x equals 9. Now the last thing that I need to do is just undo the multiplication of the 6. So I'm going to divide it. 6 divided by 6 cancels out, that's just 1. And we get x equals 9 over 6, which we can reduce. If we reduce 9 over 6, we can divide the top and bottom by 3. And that means that x equals 3/2. And that's our final answer. We can go back and check to see if that works by plugging it back in the original. You can use a calculator to do that. And kind of just double check. It's a good skill to be able to do. All right, so part B is a linear equation that involves fractions. So we want to get rid of the fractions as soon as possible. So whenever we have a fraction, let's think about what the least common denominator would be. And we have the least common denominator between 6 and 4. So if I start listing the factors of 6, I get 6. 4 does not go into 6. We could get the next multiple of 6 is 12. I said factors, I meant multiples. The next multiple of 6 is 12. 4 does go into 12. So the least common multiple or least common denominator between 6 and 4 is 12. So if I take each of my fractions and I multiply the numerators by 12, that will get rid of all the fractions. And I just have to make sure whatever I do to the left side, I also do it to the right side. So if I multiply all of my denominators by 12 on the left, I have to do it, or multiply all of my terms on the left, I have to do that same thing on the right. Now from there, we just reduce the fractions. So 6 goes into 12 2 times, 4 goes into 12 3 times, and 4 goes into 12 3 times. What that does is it actually cancels out any denominators. So then we end up with just 2 times x is 2x, 3 times 9 is 27, 1 times 3 is 3. Okay, now we're going to solve this remaining linear equation that no longer has fractions. I'm going to subtract that 27 from both sides. So if I subtract it here, it cancels. 3 minus 27 is negative 24. And divide both sides by 2. We get negative 12. So that is our correct solution for x. When you're solving linear equations, once again, it is okay to plug that in and just make sure you got the right solution. That's a really good skill, especially on a test. It's a quick way to check to see if you got it right without doing the problem all over again. Okay, question 3 says you are choosing between 2 plans at a health club. Plan A offers an initial membership fee of $75 and you pay $15 per month. and Plan B offers an initial membership fee of $20 and you pay $26 a month. After how many months are the two clubs the same? So the very first thing I like to do is figure out what am I trying to find. And it will tell me that how many months are the two clubs the same. So that is my variable. My x is going to be the number of months. Okay. Now, Plan A tells us we're going to pay an initial fee of $75. But then we're going to pay $15 per month. That's our changing number. So it's $15 per month. Well, we know that the number of months is X. So it's going to be $15 times however many months you had to pay for that. Plan B offers an initial membership fee of $20, but then you have to pay $26 per month. Okay. Now, if there's no initial fee, you would just use 0 because you're not paying anything initially. But in this case, we have $75 as our initial fee on A, $20 is our initial fee on Club B. Now, we just want to find when the price is the same. The two are the same, so we do set them equal to each other. And we solve this linear equation. So we have here 75 plus 15x equals 20 plus 26x. I'm going to subtract the 20. That gives us 55 plus 15x equals 26x. I subtract that 15 over to the right side. That's 11x. Divide both sides by 11 and we get x equals 5. So what we end up with is, after 5 months, the two clubs will be the same price or cost. Okay? So that's our final answer. We do want to show that we understand what the variable is that we solved for. So just saying x equals 5 doesn't mean that much to us. So we do need to say, okay, 5 months would even be better than just saying 5. So let your teacher know that you understand what was being asked of you on these application problems. Okay, question 4 is a little bit different. It's going to possibly a question like this, inequality. It might be something else besides an inequality, but it's going to have you analyze a problem, not just solve it. So we want to kind of think about it and think about certain things that are happening and show that you understand the question, not just that you can reproduce the question. So on question 4, it gives us this inequality. It wants us to solve the inequality and write the solution in interval notation and graph, and then we'll answer the questions to kind of help get to that solution. So what I want to think about is, first, let's find the starting point of x, meaning let's solve the inequality using set builder. Notation. Okay, that essentially just means solve it. So we have here 6x minus 5. I'm going to distribute this 9 through. 9x minus 27 minus x. So that gives us 6x minus 5 is less than 8x minus 27. I'm going to subtract the 8x over. So that gives us negative 2x. Let's add that 5 over as well. So we're going to add that 5. 2x is less than negative 22. Okay, this next step I'm going to do is very important. I need to get rid of that multiplication of a 2 on the x. So I'm going to divide both sides by negative 2. However, whenever we divide both sides by a negative, we must, and I almost just didn't, we must flip the direction of the sign. That is one of the most common mistakes I see when solving an inequality, is forgetting to flip the sign when we divide by a negative. So that means here x is greater than 11. That is our starting point. So when it asks what the starting point for x is, right here, we are just going to say it starts at 11. Okay? That's our critical value, or our starting point, or our boundary point. Okay? We want to think about that boundary point, though. I have x is greater than 11. Would that boundary point be inclusive or exclusive? Are we going to include 11 on our graph or exclude it on our graph? Because we have x is greater than 11, we are not equal to 11. So then when it says, is the boundary point inclusive or exclusive, we will say exclusive or not inclusive. We're excluding it from our graph. So then, how do we know what direction the inequality is going? We know x is greater than 11, so we are going to go to the right. Okay? We're starting at 11, and we're going to go all the values bigger than 11. All right, so now the actual writing the problem here. Starting with the graph, we have 11. We are not including 11 on our graph, so it's an open circle. And its x is greater than 11, so we have all the values greater than 11, and that is our graph. Okay, the interval notation for this, I like to write my interval notation after I've drawn the graph out because it's very visually right there in front of us. So we read the graph from left to right. We have nothing until we start there at 11. 11 is our starting point. So we're going to start at 11. We are not going to include 11. And then we go to infinity. And that is it. That is our graph. And our interval notation. Okay, so common mistake that can be made when we're solving inequalities. Okay, not flipping the sign is probably the biggest one. Not flipping the sign. Whoops. The sign when dividing or multiplying by a negative. That's one of them. Also, sometimes I'll see people flip the sign when you're just multiplying by a positive. So the sign only is flipped when you're dividing by a negative. Let's just keep that in mind. Other mistakes that I usually see on these is not knowing the greater than or less than sign, so that can happen sometimes, or mixing up the direction that you go. But other than that, the mistakes that happen are usually just computation errors. So just messing up adding or subtracting your numbers. Those are very easily avoided, so just be careful with them. Okay, so that would be a problem where we have to kind of think through the situation as opposed to just straight up solving and getting the answer. All right, on number 5, we have solve the absolute value equations. All right, the absolute value equations, the first thing you want to do is at least get rid of any of addition and subtraction on the where our absolute value is. So in this case, I'm going to subtract the 15 from both sides. And then I end up with 9x minus 1 equals negative 13. All right, we're done with this problem. We just need to write the answer. There's a huge issue. The absolute value is always positive. The inside of the absolute value can be positive or negative. But if you have an entire absolute value that equals a negative, then that means that we have no solution. So we are done with that. So whenever you have your absolute value equal negative, we have no solution. All right. Then, let's look here. That kind of changes how B, we should look at B. I have 3 times x minus 1 equals, I'm going to subtract that 4 over, so that equals 9. Okay, here I can do two things. I can either isolate the absolute value by dividing both sides by 3, or we can multiply the 3 by the positive and negative of the right side. I'm going to divide by the 3 right off the bat because it just makes the problem a little bit easier. This 3 can be divided by both sides because the entire 3 is being multiplied by the absolute value. So then, since the whole thing's being multiplied, if I divide the whole thing by 3, they cancel out. If I divide the whole right side by 3, we get the absolute value of x minus 1 equals 6. Okay. Now with absolute values, we set up the two equations. Because the inside, which is x minus 1, so x minus 1 is the inside. The inside can either be the positive of the right side, or the inside can equal the negative of the right side. So we have two possibilities. Now we just solve each of those possibilities. So we're going to add that one over. Add that one over, so we get x equals 7 here, and negative 5 on the other one. And those are our two absolute value solutions. Usually with absolute values, you'll get two solutions, unless you have like a quadratic equation or something a little bit more complicated. You can also get one solution if your absolute value equals 0, and you can get no solution if your absolute value, the entire absolute value, equals a negative. All right, this last absolute value problem, sorry about that bar there, that kind of happened when I took my screenshots. When I have absolute value on both sides of the equation, don't let these ones be harder than they actually are. They're not terribly difficult. I will just take that right side and just not worry about the absolute values on the right side. So I'm just going to replace my absolute values with parentheses. Because the absolute values repeat themselves if you were to write all 4 options, that you don't have to worry about the absolute value on that second side. Or you can get rid of the absolute value on the first side and keep them on the second. Either way. But what's going to happen, just like question B, is this 2x minus 7 is going to equal the positive of the right side, or the 2x minus 7 is going to equal the negative of that right side. And I'm going to solve each of those linear equations. So this ends up being 2x minus 7 equals 6x plus 4. I'm going to subtract the 2x over and subtract the 4 over. So I have negative 11 equals 4x. Divide both sides by 4. And I get x equals negative 11 fourths. Okay, and then also on the second one, okay, very important. If I ever have a negative outside the parentheses, make sure you distribute the whole negative through. So I'm going to go negative times 6x is negative 6x, and negative times positive 4 is negative 4. Okay, I'm going to add the 6x over. So that gives me 8x. Minus 7 equals negative 4. I could have just added the 7 at the same time, but I started writing and then I didn't. So then we end up with 8x equals 3. Divide both sides by 8, and we get x equals 3/8. So that means that the two solutions we have for these problems are that x equals negative 11 fourths and 3/8. There we go. Once again, we get two solutions, the positive that could have gone inside the parentheses and the negative that could have gone inside the parentheses. All right, question 6 is a lot like the inequality question, and this one happens to be inequality too. But it's going to get us thinking more about the problem than just solving it. All right, so on this question it says, what is the first step in solving this inequality? This is very, very, very important. The very first thing that you have to do to solve this inequality is isolate the absolute value. Okay. The reason that we need to isolate the absolute value is so that we know, here adding that 4, we know that the entire inside of the absolute value is greater than or equal to 6. Okay? It would be really difficult to say the absolute value minus 4 is greater than or equal to negative 2 or positive 2. So it's very important to isolate the absolute value first. Okay? Then, from that, we can write the two equations or inequalities that relate that greater than or equal to 6. So we know that if this were a 9x minus 3 equals 6, we know that 9x minus 3 would equal positive 6, or 9x minus 3 would equal negative 6. Okay, so if this were an equals, those would be the two equations we would solve, and then we could solve them and we're done. But to write the two inequalities with absolute values, we kind of keep that same idea, that 9x minus 3 is going to be greater than or equal to positive 6, and then 9x minus 3, instead of greater than or equal to negative 6, because we are multiplying that 6 by a negative 1, we're going to have to flip the inequality sign. So it's always the same sign of the positive, a flip sign of the negative. So to write those two inequalities, that's exactly how you do it. You just keep the same sign, positive, flip the sign, negative. Now, we would have to go and solve the inequality, and then we graph and write the interval notation. But before we do that, I want you to think about one thing. we're going to have our boundary points or our critical values or whatever you want to call them. In this case, we will include the boundary points. So those boundary points are inclusive. So we're going to include the boundary points because, can't spell because we have a greater than or less than or equal to. All right. So greater than or equal to means that we do include those boundary points. If it was not an equals to, we would not include the boundary points. Okay, solve the inequality, write the solution as a graph, and write the interval notation. So I'm going to use a different color here. So this is the actual solving. Before I do the graph, I guess I should probably solve those values. So 9x minus 3 is greater than or equal to 6. I add the 3 over. 9x is greater than 9. X is greater than or equal to 1. I do not flip that sign because I did not divide by a negative 9. I divided by a positive 9. Okay, then my other one is that we have 9x minus 3 is less than or equal to negative 6. I add the 3 over, divide both sides by 9. I get x is less than or equal to negative 3/9, or x is less than or equal to negative 1/3. So those are my boundary points. When you get into calculus and things like that, points like that are considered critical values because it's kind of where you're switching from being equal to and not equal to. So let's see, we have negative 1/3. We can be equal to, they are inclusive. So we're going to shade that in. And my other boundary point is 1. So there we go, we're going to shade that in. Now, let's start at this x is greater than or equal to 1. That's going to the right. X is less than or equal to negative 3 is going to the left. So there's my points. We've got to read that graph from left to right now. That's a lightsaber. So we're going to start at the left. We do have something until we get here at negative 1/3. We're going to stop at negative 1/3. Then we're going to jump over to 1, and then we're going to go 1 forever to the right. So we're going to start at negative infinity to negative 1/3. Remember that infinity is always a parenthesis because it's not an actual number, it's a concept. So we're going to go negative infinity to negative 1/3, bracket, or close. Then we're going to use a U to represent that we're jumping that region. So it's in this region or in the region 1 to infinity. And that is our answer. The answer of inequalities will combine the graph and the interval notation. Okay, question 7 says given the relationships, there should be a comma there, sorry, state if they are a function. This case you do not have to write the domain and range. If it helps you to write the domain and range, then go ahead. But in this case, we just need to decide is the relationship a function or not. In order to determine if something is a function, we just need to make sure that every x goes to a 1y. So we really just can't have our x repeated. So in this case I have x goes to when x is 3, y is 7, and when x is 3, y is 9. That's a problem. Because of that right there, this is not a function. Okay, so there we go. If we look at b, here I have -3 goes to 7, -4 goes to -7, 4 goes to 6, and 3 goes to 7. Now, here, I am repeating my y values, but I am not repeating any x values that go to different y's. So this actually would be a function because every x is unique. So there we go. And that's all that question is going to ask, if the relationship of the points is a function or not. Now, looking at the slope between 2 points, this is pretty simple. If we have 2 points and we need to find the slope, we're just going to use the formula, y2 minus y1 over x2 minus x1. And you can let any point be x1, y1, x2, y2. All right, so here, we're going to go, our slope equals y2 minus y1, so -5 minus 4, over x2, which is -2, minus -6. Minus a negative is a plus. So we have here -9 over 4. And that cannot be reduced. If it can, reduce it. But in this case it can't, so we are done. On B, same thing. We're going to go y2 minus y1 over x2 minus x1. So that would be 0 over 2, which is just 0. So our slope is just 0. That's great. Now, if the 0 is in the numerator, that's okay. If we do have a 0 in the denominator, our slope is going to be undefined. Question 9 wants us to use the function on the graph to find the domain and the range. So the domain, remember that will be the x values. In this case, it's going to be a range of x values that x can be equal to. So I'm going to start here and I'm going to sweep along the x. So I'm going to start from the negative and go to the positive. Right here is where this function starts along the x. So we're going to read what is that x value where my function is starting. So my x value is starting at x equals -5. Because my circle is closed, I am going to use an inclusive bracket, meaning we can be included. Okay, so I'm going to start there, and then my graph goes up, and I have something up here all the way until I get all the way down here, and this is where my graph is stopping. That is the stopping value of my function. Now that is the point 9, -8. But we're worried about what the x value is of where we stop. So because we are looking at the x value where we stop, we are stopping at 9. And the last thing on this domain here is because I have an open circle, that means we cannot be equal to that value. So that is the value where we are going to stop. So we're going to use a parenthesis, meaning that we are excluding the value. It's not included in the actual domain. Now if we look at the range, it's the same idea, but we read the y values. Okay, so the range here, this is our starting point. That is our very lowest or most minimum value. So right there. So the y value where we are starting is -8. Notice that I did use a parenthesis because we cannot be equal to -8 because the circle is open. Everywhere else on the graph, we are including the values, except for at that -8. Okay, then we go all the way up. Okay, and if we read it along the y-axis, that is the very highest y value my graph can be equal to. So right here is the maximum and the end of my range. So that range stops at 9, and we can be included, that 9 can be included. So that is my maximum y value. So that is how we find the domain and range of the function using the graph. All right, so I'm just noticing now that the test review numbered the problems wrong. So that this should be question 10, or 9, it doesn't matter. It's a problem. So we're just trying to find the slopes of the graphs that are given to us. In this case, to find the slope, we just find where we're crossing through. Here are some points we're crossing. We have this triangle. We are going to just count the rise. So in this case, we are rising 2, so we're going up 2, and we are running 1, 2, 3. So that means that our slope is 2/3. And it is an increasing slope because it is positive. Now, if you turn the page, the next 3 problems on that next page are all the same question, trying to find the slopes of the given graphs. Question B on the same problem wants us to find the slope of this vertical line. So if you can remember that the slope of any vertical line is undefined. And the main reason that the vertical line has an undefined slope is because if we look at our rise over our run, we are running 0. And anything divided by 0 does not work out. So we just say the slope is undefined. And there we go. It is a vertical line, so that's important to know. Now if we flip that around and find the slope of the horizontal line, okay, we have our slope is equal to 0. Because if we do rise over run again, no matter what we are running, we are rising 0. So our slope will always be 0 there. Question D, I'm going to zoom in because it was kind of hard to see what was happening just on the paper. So this is crossing through the point 10, 0. And then also down here, I have this cross point of -15. So if I want to find my slope here, I'm going to go do my rise, which is going down, and then my run, which is going to the right. So my rise here, I'm actually going down -25. And my run is +5. So that means my slope is a -5. And because it is going down from left to right, we say that this slope is decreasing. And that's all you need to be able to do with those problems. Just look at the graphs and try and find the slope. On the test, this multiple choice type of question, it will be very clear what the points are going through, so you shouldn't have any difficulties finding any cross points at all. Okay, page 7. So this page has a lot of problems that involve finding lines and slopes. So let's look at question 10. Question 10 says, find the slope of the line parallel and perpendicular to the given line. So the first thing that we need to do is find the slope of our given line. So we're going to find the slope here, and we will do that by putting the equation in y equals mx plus b. So I'm going to take this 3x minus 4y equals 12, and I'm going to subtract the 3x over. So that's negative 3x plus 12. And then I'm going to go and divide everything in my equation by negative 4. So the equation of my line in that slope-intercept form is y equals 3/4 x, and then positive 12 divided by negative 4 is minus 3. Okay, so the slope of my line, let's just write this, the slope of the given line is 3/4. Now we want to find the parallel slope and the perpendicular slope. So let's look at the parallel slope is the easiest because it is the same slope. So the slope of the parallel line is 3/4. The slope of the perpendicular line is, you need to flip the fraction, so instead of 3/4 it's 4/3, and change the sign. So since it's a positive, it's going to become a negative. So that would be the slope of my perpendicular line. Okay, so that's a question where you just find the parallel and perpendicular slope. We'll look at some problems where we are given a line and we have to find the equation of the line, not just the slope, but the equation of the line. Okay, question 11. This is a pretty loaded question. This would definitely not be a multiple choice question, though there might be components of this that would be in the multiple choice section. For example, finding the slope between 2 points. Okay, so what you want to do here, first, they want us to take the 2 points and what is the slope of the line with those 2 points. So we're just going to use the slope formula. y2 minus y1 over x2 minus x1. I highly recommend that you memorize that formula, or you can understand how that relationship works. That's another way to do it, by graphing the points and then doing the rise and the run. But it'll be just quicker if you do know the formula. So y2 is 15 minus y1 is 5. x2 is negative 2 minus x1, which is 3. So I have here 10 over negative 5. So the slope of my line is negative 2. That's the first thing that the question asks. Then we need to find the equation of the line in slope-intercept form. So the first thing we need to do to put the equation of the line in slope-intercept form is put the equation into point-slope form and then solve for y to get it into slope-intercept form. So point-slope form means that we just need to take any point and the slope. So in this case, I'm going to use my slope as negative 2, and I'll use the point 3,5. You can also use the point negative 215. It doesn't matter which one. Okay, so then I'm going to plug that information in. So y minus the y point is equal to our slope, which is negative 2, times x minus the x point. Now that we've put everything into the equation, we're going to solve for y. So I've got y minus 5. I'm going to distribute the negative 2 through. Negative 2 times x is negative 2x. Negative 2 times a negative 3 is a positive 6. And then let's just add that 5 over. We get y equals negative 2x plus 11. So that would be the equation of my line. The last thing that we want to do with this equation of the line is graph it. So I am going to first find my y-intercept, which is 11. So I'm going to go up to here to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's my starting point. That's my y-intercept. And then my slope is -2, which means that we rise -2, run 1. Maybe rise isn't the best word because we're rising. We're actually falling though because it's negative. So we're going to go down 2, run 1. Down 2, run 1. So you can do that as much as you'd like. And then we just connect the points and we have our line graphed. Now my x-axis was spaced out a little more than my y-axis, so this actually probably would be a little more steeper if everything was spaced out evenly. But how you do your tick marks, it actually doesn't matter as long as you show that your starting point is at 11 and you are rising 2, running 1. So that looks like this. Sorry, we're rising -2, so we're going down 1, 2, run 1. You can do that again, go down 2, run 1. And you can do that however many times it takes to get to draw a nice straight line. Question 12 and 13 kind of use the exact same points and line, but we want to find the equation of a line that is perpendicular and the equation of a line that is parallel. So remember that when we're writing the equation of a line, there's essentially 3 steps that you must do. On the last problem, 11, it walked us through those steps. So on 12, we're going to have to kind of come up with those steps on our own. The first thing that you need to do when you're writing the equation of a line is we need to make sure we know what the slope is. So we need to find the slope. Find the slope of the line we're trying to write. In this case, they tell us that our line is perpendicular to 3x minus 4y. I'm just going to take this 3x minus 4y and we already worked with it, but I'm just going to redo this one more time. Divide everything by -4. And I'm going to put this line into slope-intercept form. So here's the equation of my line in slope-intercept form. So the line that we are given has a slope of 3/4. Okay, but we're not looking at the line we're given. We're trying to find the slope of the line that's perpendicular to the line given. So the slope that is perpendicular to 3/4 would be -4/3, the negative reciprocal. Okay, after you find the slope, the next step in writing the equation of a line is to take your slope and a point and put that information into slope-intercept form or point-slope form. I keep mixing those up. Slope-intercept form is what we're trying to put it in the end. Point-slope form is what we need to use as a tool to get the equation into slope-intercept form. So we have our point 2,5 and our slope -4/3. So we're going to go y minus 5 is equal to your slope, which is -4/3, times x minus the x point, which is 2. Now the last thing we need to do after we put all the information into point-slope form is solve for y. That's probably the hardest part of these problems. So if we do have y minus 5 equals -4/3 x minus 2, I'm going to distribute the -4/3 through. So that's negative 4/3 x. And then negative 4/3 times negative 2. If you want to put it over 2 over 1 because it's helpful, you can. But we're just going to keep that as positive 8/3. Okay, then the last thing we need to do here is just add that 5 over. And this can be kind of tricky because you have those fractions to work with. We do know we have negative 4/3 x, but then we have to add 8/3 plus 5. We're going to rewrite 5 so that it has a common denominator as the 8/3. So that's 8 plus 15 is 23/3. So it's y equals negative 4/3 x plus 23/3. And that would be the equation of the line perpendicular to the line that they gave us through the given point. Okay, question 13 kind of follows along with question 12. It asks pretty much the same question using the same numbers and everything, but instead of a perpendicular line, we're looking for a parallel line. So, same thing here. We found that the equation of 3x minus 4y equals 12 in slope-intercept form was 3/4 x minus 2. So we know that the slope of the line parallel to our line is 3/4. So the first thing we need to do to find the equation of the line is find the slope. And we know that the parallel line slope is 3/4, and parallel lines have the same slope. So our line also has a slope of 3/4. Now, we are going to put that information into point slope form. So y minus y1 equals m times x minus x1. We have our slope and our point here. So minus the y point is equal to our slope, which is 3/4, times x minus the x point. Okay, now the last thing here is we solve for y. Alright, so I'm going to distribute that 3/4 through, so that's 3/4 x, and then 3/4 times 2 is 6/4, which is 3/2. Okay, now we just add that 5 over. So we have 3/2 plus 5. If we create a common denominator, multiply that by 2, that's 10. Negative 3 plus 10 is 7/2. So our final equation is y equals 3/4 x plus 10 minus 3 once again, 7/2. And that is the equation to our line. So depending if our line is parallel or perpendicular, really affects the slope and then how you do the problem. Alright, last page here. Henry got a new job. The annual pay for the job follows the linear function y equals 34,000 plus 3,500x. When x is the number of years Henry has been working for the company. Okay, so if we're just looking at this linear equation, we have a value that is on our x and a value that does not have an x. That 34,000 is our starting pay, or our y-intercept. So Henry's starting pay is 34,000. That is our y-intercept.
per year. Okay, so we have that equation. Now, how much will Henry's annual salary be after 20 years? Well, the 20 years, that's our time or our x. So we know that x is going to be 20. Our annual salary is our y value. So we're trying to find our y. We're going to plug 3,500. We're going to plug 20 into that equation. So that would be 34,000. And then 35 times 2 is 70. 3 zeros. So if we calculate that out, we get $104,000 per year. Now, the next question says, how many years must Henry work to have an annual salary of $93,500? So that is our y value, and we're trying to find our x. So I'm going to plug 93,500 in for my y. 34,000 plus 3,500 x. So I'm going to subtract that 3,400 from both sides. And we end up with, 59500. That equals our 3,500x. So I'm just going to divide that 59500 divided by 3,500. Let me try that one time. We get x equals 17 years. So 17 years is how long it's going to take to get to a salary of $93,500. So this is a great application of linear. Now it's not always, when you find a job, you're not always going to increase at a linear amount, but it's a good way to get to see how the relationship would work. Okay, the last thing in this unit was solving system of equations. This system of equations, we can pick what method you want to use to solve them. If my equations are set up where the x and the y are on top of each other and then they equal the constant, I will always use the addition method because I think the addition method should be pretty quick. If I do have something solved for already, then I would use substitution. Alright, so in the case of this first one, I have 3x plus 2y equals negative 8. 2x plus 5y equals 2. I think that the easiest thing here would be to get rid of the y, because 2 and 5 are kind of easy numbers to multiply by. So I'm going to multiply my top one by negative 5, and my bottom one by 2. One of the signs has to be a negative and one's positive. Since they're starting out both positive, I need to distribute the negative by 2. So negative 5 times 3 is negative 15x. Negative 5 times 2 is negative 10y. And negative 8 times 5 is 40. Then I'm going to distribute the 2 through, so that's 4x plus 10y, and that is going to equal 4. Okay, now my y's are the same value but opposite signs, so I can add the two equations together. Negative 15x plus 4x is negative 11x. The y's do cancel out, so we have equals 44. Then we're going to divide both sides by that negative 11 to solve for my remaining variable. find the y that goes with that x. So we can use any equation as long as there's a relationship between x and y. So I'm going to take this 2x plus 5y equals 2. And I'm going to plug that negative 4 in for x. So we end up with negative 8 plus 5y equals 2. And then add that 2 over. So we've got 5y equals 10. Divide both sides by 5 and we get y equals 2. So the solution to my system of equations is the point negative 4, 2. That's one way to write the solution. You can also just write x equals negative 4, y equals 2. But if you write them, they need to be next to each other. Because teachers really don't like searching through all the work of a problem just to find the answer. So you always want to write the answers, especially if there's multiple answers, next to each other. Alright, so that is the first one. Let's look at the next one. Alright, so in this case, there's a couple options here. We can get rid of the x's by just multiplying the bottom by negative 3. Or the y's are opposite sides, which is kind of nice. So then we can multiply the top by 5 and the bottom by 7. I think that the easiest thing to do though is just multiplying that bottom one by negative 3. So let's take a look here. Then we end up with 3x minus 7y equals 20. We did not change that equation at all. And then we're going to distribute that negative 3 through. So it's negative 3x minus 15y equals 24. Okay, so we're going to add our y's together and our x's together as 0. Negative 7 minus 15 is negative 22y. And that equals 44. Goodness, lots of 11s here. There we go. And we get y equals negative 2. Now we need to figure out what x is based off of what our y is. So I'm going to, let's just plug it into this top one. So we have 3x minus 7 times negative 2 equals 20. So 3x plus 14 equals 20. 3x equals 6. So x equals 2. So our solution is x is 2, y is negative 2. Now, your solution can be fractions. I'm just mentioning that too for probably an important reason. Just make sure whatever answer you get, you plug the value into any equation to find the corresponding point that goes with that. Alright, the last one here. Let's take a look at this. We've got 4x minus y equals 7 and 2y equals 8x plus 15. So we can use substitution. side through, like that. The 4x and the 4x, they're going to cancel. And then we are left with negative 15 halves equals 7. This has no variables. It is also a false statement. So because we have no variables and a false statement, our system of equations has no solution. What that really means is our lines are parallel. They're never going to cross. So there we go. No solution. All that work for nothing. Now if we end up with an equation at the end where our variables went away, but the equation was true, so maybe we had 0 equals 0, or 5 equals 5,